So I want to talk about the time difference between the P wave and the S wave, because this is going to be critical for us in figuring out distances. So I want to give you a really cheesy little example here first. Let's say I'm at a train station. Let's say this dash here is train A, and over here we have train B. Let's say they both leave the station at the same time. So here we've got this guy and this guy. But let's say this car here is going 50 miles per hour, but this car is going 70 miles per hour. So obviously here we start at the start, right? They're about the same spot. Let's go 5 minutes down the road, and what we'll see is the car going 50 miles an hour is starting to move behind the car going 70 miles an hour. If we wait and go 15 minutes down the road, what we'll see is the car going 50 miles an hour now is way behind the car going 70 miles an hour. So the further you get down the line, the bigger the time gap gets between the two cars. This is the same thing here. So if I have an earthquake, and right here my epicenter, right, or my focus is, right, where the earthquake generates, my P wave, right, is going to go out first. And my S wave, well, they're generated at the same time. However, because, right, the P wave is faster than the S wave, we have that same distance issue. But instead of distance, it's going to be time. So what we'll see is our little recording station here will get the P wave information first, and then let's say maybe 5 minutes later, then it gets the S wave. So we can make a direct correlation between the time lag between the arrival of the P wave and the S wave to determine distance. So the greater the time lag in between, the greater the distance. And that's what you saw on the previous slide with the time travel curve. Because the continent is pretty much almost always made of granite, right? It's mostly made of that. We can say that our waves travel roughly at about that same speed. The P wave's always going to travel at a pretty similar speed, and the S wave's always going to travel at a pretty similar speed. So we can always use that time gap now to get a distance.